business. Let me handle my business. Let me handle my business.
Circuits are all about electricity. In real life, we cannot live without electricity. In the wire, there's something called electrons. They are everywhere, although we cannot see or touch them.
Cool. So this is a wire. So
In the wire, there are electrons. If it's not plugged in, it's not moving. But if it's plugged in, the electrons will begin to move.
and electricity exists when they are moving.
So they usually stay in their positions, which means they are stationary and not moving because there is no force causing them to move. But if there is a force, they will move and the electricity exists. So what can lead them to move? The answer here is a term called voltage. Symbol voltage is V. Voltage is the force that motivates electrons to move or flow. Voltage usually comes from a power source. Batteries are one of the most common power sources which have voltage that lead electrons to move in order to generate electricity. So we got batteries and wires, which means we can make a circuit. A circuit is basically a loop that allows electrons to flow continuously. If we link a light bulb to the circuit loop, it will glow.
So this is a circuit. We got a power source, which is a battery, and the battery makes the electrons flow from that way, and then there's a light, a lamp. So because of the flow of electrons, the lamp lights up, and then the electrons flow through the circuit continuously. So this is a real picture of a circuit. There's a battery, two batteries, wires connected to the light bulb. So when electrons flow from the batteries to the light bulb, it lights up.
Electricity can flow only if there is a complete circuit from the battery through wires to the light bulb and back to the battery again. An incomplete circuit is like the wires are not connected to the batteries or they are broken, which stop the flow of electrons. When electrons are moving, they have a speed. Current is the term of how fast the electrons are moving in the circuit. There is also a term called resistance. It is basically the opposite of voltage. Voltage is the force that leads the electrons moving. Resistance is the thing that slows down the movements of electrons. Resistor is a common source that provides resistance. There's a law that describes the relationship between the voltage, resistance, and current. It is called Ohm's law. And there's the man himself.
Ohms.
Yes, Ohms. The equation of that law is V equals IR, or I equals V over R.
Oh.
And from that equation we can know that current, which means how fast the electrons are moving. It is directly proportional to voltage and inversely proportional to resistance. So when V increases, I increases. When R increases, I decreases, which means the electrons are moving slower. This is consistent to what we talked about before. We did an experiment to prove the Ohm's law. Our setup, which consists of a resistor, batteries, and also an ammeter to measure current.
So this is our setup. At first, we connect a battery to the circuit, which provides voltage to make the electrons move. And there's a resistor which slows down the movement of electrons. And there's an ammeter which we are using to measure current. resistance as a control variable. This one, the resistance remains the same in the whole experiment. And voltage, which V stand for, is the independent variable. We change the amount of batteries to change the voltage. We use 10 data points in this experiment, which means we start from using one battery, which provides 1.5 volts first, and then we keep adding one battery each time, which means we add 1.5 volts each time until we have done 10 batteries. And I, which stands for current, is our dependent variable. We are observing while we are changing the amount of batteries. We use an ammeter which connects to the circuit to measure current. Don't know how to do it. What?
Show everything.
Resistor. What's that? Battery.
We need 10.
No, we don't show it now. That's all.
Number 2, batteries.
One more.
Yeah.
It cut off right now.
Yeah. Go. Now we are showing you the data that we collected. This is 1.5 is equals to 1 batteries, and we have 10 data points. The last one is 15, which means we use 10 batteries at the last time of our experiment. Done! So, after we got all of our data, we plug in all the data into Logger Pro. So, this is our data. And we use this data to make a graph, which is a and we also use the Logger Pro to find the slope is about 8,010.
This is our mathematical model from Logger Pro. V equals 1,010 currents times currents.
Now, as V increases, I also increases. I is directly proportional to V.
And if you compare to the Ohm's law, we'll find that this V I, you'll find that 8010 is basically the resistance. This is the guy. What's his name? Ohm. Yeah, Ohm is who it's called. So you'll find that this 1010 is our constant, which is our resistance. Hey.
Hey.
After that, we want to make sure the constant, which is resistance, is accurate. So we measure the amount of resistance in the resistor by connecting the resistor to a multimeter. So this is the resistor, and we connect it to multimeter to measure it the resistance. So it's 995 about, which is approximately the same as our result, which is 8010. Done. What? That's bullshit.
All right, we got 1010 ohms from Lager Pro, and
For the constant
for
R,
constant R, and we got 995 ohms.
by measuring
from-
directly.
Yeah, from the multimeter.
Yes.
What they give you? Lifetime supply, making soda clientele. A rolling wine, 2 gangsta Brazil.